welcome back to Differential Calculus. In this competitor for the longest video title in the course, we're going to be looking at the derivatives of trigonometric functions. Once again, the details of how these derivatives were found are very tedious and not all that useful, so I'm going to skip over that and jump in just with giving you the rules. The rules tell us that the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to the negative of sine of x. But these rules only work when x is in radians. If you have x in degrees, you're going to end up with factors of 360 and pi just sprinkled throughout. It's annoying. We don't want to deal with it. This is why when we talked about trigonometry earlier in the course, I said we're going to stick with x always in radians. It makes things work. All right. And while I don't have a proof to give you, I do want to look at the graph of the sine and cosine function, because the fact that they are so closely related in this way, at least to me when I was a student, was incredibly surprising. Remember that the derivative of a function gives the slope of the tangent line. And so if we look at, I have here the, I think it's bluish. I've mentioned before, I'm colorblind. I have no idea. But it looks like it's probably a pale blue here, maybe green. This curve is the sine function. And from right here at about negative pi over 2 up to here at about positive pi over 2, the sine function is tending upward. That means it has a positive slope. Before that and after that, the graph is tending downward, which means the tangent line would have a negative slope. And then look at the cosine function. Right there, it switches from being negative to positive, giving us a positive slope on the tangent line, which continues until the sine function turns around, at which point it's negative again. And then the cosine function. Cosine function is increasing over here, but from right here, when x is equal to 0, down to when x is pi, the cosine function is decreasing. So its tangent line should have a negative slope. The sine function is positive, but remember, if I go back to my notes, the derivative of the cosine function is the negative of sine. So this actually works exactly the way we want it to. If sine is positive, the negative of sine is negative, giving us a negative slope for the tangent line for cosine in this region where it's descending. That's not a proof that these are going to work out and have such a close relationship, but it's a little bit of evidence to help support that. So these two derivatives are very straightforward. We can make things messier. By including other stuff hanging around with them. If I want to take the derivative of 2x sine x, this is the product of two functions, 2x multiplied by sine. So I can take the derivative using the product rule. The derivative of 2x times sine x plus 2x times the derivative of sine x. The derivative of 2x is just 2, and the derivative of sine x is cosine x. So the derivative of 2x sine x is 2 sine x plus 2x cosine x. Another example here. if I want to take the derivative of cosine of x squared. Now the interesting thing is happening inside the argument of cosine. So in order to work with that, we're going to use the chain rule. The derivative of cosine is the negative of sine. Evaluate that at the same argument. Then multiply by the derivative of the argument. The derivative of x squared is 2x. Clean that up a little bit. Negative 2x sine of x squared is probably a nicer way of writing that derivative in. Now that we have the derivative of sine and cosine, we can take a look at the other trigonometric functions. Tangent the ratio identity tells us is sine of x over cosine of x. And we can take the derivative of this using the quotient rule. Derivative of the numerator, derivative of sine is cosine, times the denominator, cosine, minus numerator, sine, times the derivative of the denominator. Derivative of cosine is negative sine. All divided by denominator squared. Cleaning up from here, we get some really nice things happening. Cosine x times cosine x is cosine squared x. Minus and minus is plus. We have sine squared x. And then we have cosine squared x in the denominator. Really making our life easy. Cosine squared plus sine squared is 1. And then finally, using the reciprocal identity, 1 over cosine is the same thing as secant. So the derivative of tangent x is secant squared x. I would like you to do the same thing for secant. This is another very common one. Knowing the derivative of secant offhand is going to be useful to you. You can easily look it up in a table of derivatives in our textbook or online, so you should be able to find what the solution is without much issue. That's not what I'm asking for. I'm asking you to think about the trigonometric identities and using the derivative of tangent that I just worked through, see if you can figure out how to find the derivative of the secant function. Take a couple of minutes and play around with that, and then I'll see you in the next video.